Hi, it's me, Tim Dodd, the Everyday Astronaut. We're at a really exciting time where the number of crewed vehicles going to the International Space Station will go from just 1 to 3. The Soyuz's 8-year monopoly for getting humans up to the International Space Station is finally coming to an end. So today, we're going to take a deep dive on the 2 new spaceships that are going to be responsible for taking humans to and from the International Space Station from the United States. So we're going to compare the Boeing Starliner riding an Atlas V rocket to SpaceX's Crew Dragon on their Falcon 9 rocket. And to see how far we've progressed in the world of human spaceflight, we're also going to compare all these systems alongside Russia's Soyuz capsule and the United States' retired space shuttle in a side-by-side comparison. We'll take a look at the designs, the rockets they ride, the dimensions, the costs, the safety considerations, and any other unique feature that each vehicle offers. Considering I've been up close and personal with SpaceX's Crew Dragon capsule and Boeing's Starliner, I think I've got some pretty good insight on these vehicles. Let's get started.
3, 2, 1, liftoff.
That's one small step for man.
Contact with a test 1.
The International Space Station is still one of the greatest feats of human engineering. I mean, after all, it's a football field-sized floating laboratory traveling 10 times faster than a bullet, circling the Earth every 90 minutes. It's taken 33 launches to put all of its pieces into orbit and has been home to over 230 people from almost 20 countries. The ISS typically has 6 astronauts on board. Crew are sent up in groups of 3 and usually reside at the station for 6 months. There is typically a 3-month overlap for existing crew and newly arriving crew. But since the space shuttle program ended in 2011, there's only been a single ride to the ISS. That's Russia's Soyuz vehicle. But we're coming up on a really exciting time as the United States prepares to send US astronauts to the International Space Station from US soil on 2 brand new spaceships. And what I think is most exciting is NASA has hired private companies to do the development and the operations in a new program called the Commercial Crew Program. The 2 companies that won the contracts are SpaceX and Boeing. I'm not really going to get into how the Commercial Crew Program got started or has progressed in today's video. I mostly want to talk about the hardware, starting off with Boeing and their Starliner. Boeing started designing the Starliner, originally known as the CST-100, in 2010 after winning a contract from NASA for the CC-DEV program. The Starliner is a traditional truncated cone capsule design, much like previous spacecraft from the United States. It can carry up to 7 astronauts at a time, although NASA won't use more than 4 seats at a time. The Starliner will be the first orbital capsule to land on solid ground in the United States. Now, this is similar to how the Soyuz capsule lands, and also how Blue Origin's suborbital New Shepard capsule lands. There are 5 landing sites proposed in the western United States, but the 2 prime sites will be the U.S.'s Army White Sands Missile Range in New Mexico, and the Army's Dugway Proving Grounds in Utah. Starliner will land using parachutes and a set of large airbags. A pair of drogue chutes are deployed at about 9 kilometers in altitude, followed by a trio of main chutes at 3.6 kilometers, and at 1.5 kilometers in altitude, the heat shield is ditched and the 6 airbags are inflated. These airbags serve a dual purpose. In nominal cases, the airbags will soften the landing when landing on land, and in off-nominal cases, like an abort or an emergency re-entry, the airbags offer buoyancy and balance for water landings. Touching down on land will allow the Starliner an easy path to refurbishment and reusability. Boeing is hoping to be able to turn one around in just 6 months and reuse them up to 10 times. That's definitely a good thing. Since the crew will land on solid ground, recovery of crew is quite different than a splashdown. On the edge of the landing zone, there will be a mobile data tracking vehicle, or MDTV, as well as a mobile landing control center, or MLCC, as well as a host of recovery vehicles waiting to pounce. Once touchdown is confirmed, a small army of vehicles will race their way across the desert. Now, I picture this pretty much being like a real-life Mad Max scenario, so Boeing, please send us videos of this. Upon arrival, a crew will check and stabilize the hydrazine fuels and then ground the vehicle for static electricity. After that, an HVAC truck will roll up and start to cool the spacecraft, including the crew and the fuels. Next up, a mobile landing platform will pull up with stairs and begin to evacuate the crew. Boeing has to pull crew out within 1 hour and cargo out within 2. The person who actually extracts the crew is a member of Boeing's fire and rescue team, which I think is pretty cool. The crew is taken out and then sent over to a truck for medical checkups and then whisked away on a NASA helicopter. Eventually, the capsule itself will be loaded up with a small crane truck and taken back to begin refurbishment. The cockpit of Starliner takes a fairly conservative and familiar approach. Although it's a lot less cluttery than the space shuttle's cockpit, it still features familiar and traditional controls, buttons, and non-touch screens. The Starliner will dock to the ISS and not berth. Docking is where the vehicle actually does all the final maneuvering until it connects itself up with the docking port. Dragon 1 and Cygnus cargo vehicles both currently berth to the station, meaning they park and then are grappled to the station via the Canadarm, or Canadarm. Astronauts get in and out of the side hatch when on Earth, but when docked, they'll crawl through the top part that connects to the International Space Station via the International Docking Adapter on the ISS. Initially, getting into and out of the Starliner is admittedly a bit cumbersome. Astronauts need to shimmy into their seats lying on their backs. The spacecraft is two main sections, the crew module and the service module. The crew module is, well, exactly what you'd think. It's where the crew goes. It's also the part that survives re-entry. The service module houses propellant tanks for orbital maneuvering, the orbital maneuvering thrusters, the launch abort motors, which are on the bottom in a pusher configuration, solar panels on the bottom, and radiators on the sides, as well as a host of other things. The abort motors are 4 Aerojet Rocketdyne RS-88 Bantams modified to run on hypergolic fuels to function as a launch abort motor. The first uncrewed test flight OFT-1 will fly with the qualification test motors, but they'll be inactive since there will be no crew on board. In the event of an issue with the booster or a rapid unscheduled disassembly, these abort motors would be used up until a few minutes into flight, after which time the vehicle would just use the maneuvering thrusters. The Starliner offers a full envelope abort window, meaning the astronauts can abort at any time and remain safe. Boeing designed the Starliner to be able to ride on a variety of rockets, including the Atlas V, the Delta IV, and the Falcon 9. They wound up selecting United Launch Alliance's Atlas V for now, and eventually ULA's upcoming Vulcan rocket will likely fly Starliner. The exact Atlas V they selected is an N22. Now here's a quick reminder of those numbers. The first part of the name represents the fairing size, the options being 4 meters, 5 meters, or N for none. The middle number is the amount of strap-on rocket boosters and can range from 0 to 5. The last number is the number of RL-10 engines on the Centaur upper stage. The Centaur can have 1 or 2 RL-10s. So putting this all together, the Atlas V that will launch the Starliner will have no fairing since it has a Starliner on top. It'll have 2 solid rocket boosters and dual RL-10 engines on the upper stage. Hence, the N22. When the Starliner launches, it'll be the first time ULA's actually used a dual RL-10 Centaur upper stage on the Atlas V. However, the dual-engine Centaur has been flying since 1962 and flew on the Atlas III as recently as 2005. So it's definitely not anything new. So why are Boeing and ULA using a dual-engine Centaur when the Starliner is relatively light? The RL-10 engine is crazy efficient, but one thing it's not is powerful. In order to allow for enough time for a standard single engine to push the upper stage and its payload into orbital velocities without re-entering the atmosphere, the first stage of the Atlas V usually lofts itself into an extra high altitude, allowing for more time for the upper stage to do its circularization burn. This works great for standard payloads, but in the case of an abort, this trajectory is actually way too steep, generating crazy high, unsurvivable G-forces when it hits the atmosphere. So in order to maintain a nice, safe, shallow profile for the fragile and precious humans on board, the upper stage needed more oomph. And the solution to that was the dual-engine Centaur. If you need more info on this unique engineering solution, Scott Manley has an awesome video on it. Boeing and ULA will also be running a secondary flight computer that'll be running in parallel to the primary flight computer on the Centaur upper stage. It'll catch any errors in the flight plan faster than a human reaction time, shutting down the engines and triggering an abort. Another design consideration is due to the blunt nose of the Starliner. You'll see these little lattice structures around the outside. The Starliner was designed to be as stable as possible for re-entry, which means having a short and stout design. The lattice structure helps diffuse the airflow over the vehicle, helping to make sure there are no shock waves or inadvertent pressure areas over the lower portion of the vehicle on ascent, especially since the rocket actually tapers down to the skinny Centaur upper stage. They also added an aerodynamic skirt to ensure smooth airflow. Despite the Apollo spacecraft being a similar shape, the Saturn V it rode on top of kind of wedding caked out, tapering wider and wider, and therefore didn't have those design considerations. Starliner astronauts will take off from ULA's launch pad SLC-41 at Cape Canaveral Air Force Station in Florida. The pad has already been fitted with the crew access arm in preparations for the first crew launches. This will be the first time humans have launched from this particular launch pad, which is awesome, and also the first time humans have launched from Cape Canaveral Air Force Station since Apollo 7 in 1968. We'll get into the dimensions, the designs, prices, and more when we do a side-by-side comparison of all the vehicles. Now on to the other new spaceship, SpaceX's Crew Dragon, or Dragon 2. Dragon 2 is the follow-up to SpaceX's very successful Dragon capsule that has flown cargo to and from the ISS since 2012. The Dragon capsule was originally called Dragon Rider when it was initially proposed to NASA for the CC Dev program. SpaceX was not selected for the first round, perhaps because the Dragon capsule had noses all around it, but SpaceX was selected during the second round of contracts. The original Dragon Rider capsule was essentially just a crew-rated version of their Dragon capsule, which at the time was getting ready for its first test flights to orbit and was already on contract to resupply the ISS, which it would later do in 2012. In 2014, SpaceX revealed the updated version of the Dragon capsule, which would carry astronauts at their headquarters in Hawthorne. The Dragon 2 was a massive redesign of the original Dragon capsule, including seating for up to 7 astronauts, although again, NASA won't be using more than 4 at a time for the commercial crew program. Dragon 2 was originally planning to also touch down back on land using the abort motors, assuming they weren't used for an abort, to come to a nice soft touchdown anywhere. However, due to a few reasons, SpaceX ditched propulsive landings and will do a parachute recovery and splashdown in the ocean, much like the current Dragon capsule. If you need to know more about why SpaceX canceled propulsively landing their Dragon capsule, I've already got you covered. The Crew Dragon's primary landing zone is the Atlantic Ocean, which is different from the current Dragon capsule, which has been splashing down in the Pacific Ocean since its first launch and recovery in 2010. SpaceX also filed to have the Gulf of Mexico be a contingency landing site too, which I believe would be a first. SpaceX has a pair of ships named Go Searcher and Go Navigator that'll be in charge of crew recoveries. Go Searcher features a hoist capable of lifting the Dragon capsule onto the deck and then offloading the crew. There's communication relays and a helicopter landing pad to get the crew home after splashdown. Go Searcher has been part of SpaceX's fleet for a while. Aiding in the recovery efforts of Falcon 9 drone ship landings, it looks like it may now serve a dual purpose, depending on the mission. Despite the ocean landing, SpaceX does have refurbishment and reuse plans for Dragon 2, although not quite like you might be thinking. Refurbished Dragon 2s won't carry humans again, but they'll eventually be used to carry cargo for CRS-2 missions. SpaceX already has experience refurbishing splashdown Dragon capsules, and has reflown 5 Dragon capsules to date. Although, according to Elon Musk in 2017, he mentions it's almost as expensive to refurbish the splashdown Dragons as it is to build new ones. But I'm sure since then they've implemented streamlined processes, which have helped make the efforts worthwhile. The design of the Crew Dragon capsule is extremely minimalistic. It's easy to see that the design was influenced by Elon, who likes things simple. The interior looks like the Tesla Model 3 of spaceships compared to Knight Rider's car kit. Some unique features of the interior are touchscreens and movable chairs. When Dragon 2 was first revealed, Elon sat in a seat and pulled the screen down to him. That's now reversed as the screens are stationary and the seats move up to them. Again, just like the Starliner, the Dragon 2 is designed to be fully autonomous, with manual overrides really only there as contingencies. But the Dragon 2 does something that the old Dragon 1 couldn't do, and that's dock. Getting into the Dragon capsule is done via the side hatch. Once you poke your head in, it's very spacious and minimalistic. It's easy to plop into the seat and get comfy. I actually really think this layout makes sense. Like the Starliner, the Dragon 2 is actually 2 sections as well. There's the crew module and the trunk. The crew module is again the part that holds the humans, but it also has the Super Draco abort motors integrated onto it. Since this portion of the spacecraft is recovered, the Super Draco motors are also recovered. Yay! Just like the Starliner, the Super Dracos run on hypergolic propellants and offer a full envelope abort window as well. The trunk is an unpressurized section of the spacecraft, just like it is on Dragon 1. This allows for the ability to take up larger components that wouldn't fit through the docking port, or items that are installed on the outside of the station. Items that are inside the trunk are retrieved via the Canadarm2 or another arm named Dexter. The trunk of the Dragon 2 offers a unique layout with stationary solar panels covering one side of the vehicle and radiators on the other side. The old Dragon 1 had extending solar panels. This makes sense because you want the solar panels to be facing the sun, and you want the radiators away from the sun. So, Pretty cool design. The trunk also has some fins to help stabilize the vehicle in the event of an abort. And again, I already did a video all about this, so if you want to learn more about the fins on the Dragon and why they matter during an abort, check out this video. The trunk is detached prior to re-entry and burns up due to a lack of a heat shield. This allows for disposal of some on-station items as well. A very fiery garbage service. The Dragon 2 is designed to exclusively fly in the Falcon 9, although there were plans for it to fly in a Falcon Heavy at one point, but SpaceX no longer plans to human certify Falcon Heavy and instead is focusing on Starship. In order for the Falcon 9 to be crew rated, NASA required a design freeze of their Block 5 variant, since SpaceX tends to upgrade their vehicles so frequently, they sometimes introduce unintended consequences. Part of this design freeze also required the use of a new composite overwrapped pressure vessel, or COPV. The COPV failure was the root cause of the AMO 6 pad anomaly, and a COPV strut was the cause of the CRS-7 failure. SpaceX started flying a newly designed COPV at the end of 2018. It's kind of unusual that NASA required a design freeze. I mean, considering NASA has considered flying humans on the second launch of SLS. Or even more crazy, there's even been talks of them putting humans on the first flight of SLS. But SpaceX is known to make changes all the time in the constant pursuit of improvement. So I think a safer, more conservative approach is a good idea when human lives are involved. The Falcon 9's flight profile with the crew also had to be altered compared to the cargo versions to ensure the safest profile in case of an abort. Due to the shallower, flatter profile, it also means the first stage booster of the Falcon 9 will not do a return to launch site landing and will have to land downrange on the drone ship. The upper stage of the Falcon 9 uses the Merlin 1D vacuum engine, which is extremely powerful, but not very efficient. It will have no problem maintaining a shallow profile. Crew will climb on top of a Block 5 Falcon 9 poised at Launch Complex 39A at Kennedy Space Center in Florida. Now I have to say, not that it's a contest, but SpaceX definitely does have the coolest launch pad ever. I mean, after all, this is the same launch pad that humans took off from to go to the moon. Crew will go up the fixed surface structure that's a relic from the space shuttle era. Although SpaceX has done a lot of work to remove the rotating service structure, repaint the tower, add cladding, and attach their mobile access arm. One thing that SpaceX will be doing that's completely new in the world of human spaceflight, and actually took some convincing to make NASA consider a valid option, is a load and go fueling procedure. Since SpaceX uses super chilled propellants, they need to load them up into the vehicle as late as possible so they don't warm up and boil off before the vehicle takes off. SpaceX actually continues to fuel the rocket up until just 3 minutes before liftoff. Now, clearly 3 minutes isn't nearly enough time to get up the tower and strap the crew into the Dragon capsule and then leave the tower, so the crew will actually enter before propellant load and will remain on board while the vehicle is fueled up. I can clearly understand how this is different, but I actually feel like it's kind of a safer move. I mean, this means the astronauts and the ground crew never need to approach a fully loaded vehicle on the pad. Once fuel starts flowing, the crew is actually in the safest place imaginable, a tightly sealed pressure vessel armed with a powerful abort system. So despite the process of fueling up being pretty risky, the crew is in a very safe place. Can you imagine? This will be the first time in history a human ear will hear the sound of cryogenic fuel flowing into the vehicle. They'll hear all those creaks and strains of the vehicle as it comes to life. That's going to be crazy. Another fun fact is the crew will arrive to the launch site in Tesla Model X's. Of course. Man, SpaceX will be putting on a new show, that's for sure. Now lastly, before we get to the direct comparisons, did you know both launch pads have an amusement park ride? Well, not quite, but each pad does have an emergency zip line capable of evacuating astronauts and ground crew in a hurry in the unlikely event of, say, a leak or a fire. While I'm sure there's limited use cases when this would even be remotely useful, it does look like it'd be pretty fun. Well, assuming you're not being chased by a fireball. Okay, wow. Enough of the rundown. It's time to compare these vehicles side by side and see how these new vehicles compare to the Soyuz and the Space Shuttle.